let's look at these problems over here and to see how we can actually do these problems. Try to see if there is a way that we can avoid complex computations. All right, let's look at the first problem. First problem A over here asking us to show the following thing, that on one side you have MRTS over x1, x2 multiplied by d of x1, x2 and divided by dmRTS. And we want to show this is the same thing as rather complicated expression over here. This is the one we have, f1 squared over x1 and plus f1 f2 x2 and over f2 x1 x2 and f2 partial m partial x1 and minus partial m partial x2 and f1. So this is the problem. So how can we look at this problem over here? In fact, the book's original formula was wrong, so I'm going to just explain how we actually can convert from the left one to the right one. What's the idea? First of all, we already know that this MRTS is f1 over f2 and is defined by dx2 dx1. So this is the one we actually going to use. And we have two differentials in the left-hand side. Here is a differential, and here is another differential. And we compare both sides, and we try to see what are the differences. First of all, you see that on the left-hand side, we have already over here, this is f1 over f2, right? And if you look at the right-hand side, we can factor f1 out. So we can see f1 over here is a common factor over here. And also we have f2 over here. So really we just need to show the following thing. We need to show, ignore MRTS, this is the one we need to show. This is the one that we actually need to show, dmRTS. And here then we have f1 x1 and plus f2 x2. And here we have x1 x2. And then we have f2 partial m x1 minus partial m and partial x1 f1. Now it's easier to work from left to right, so we try to do the calculation over here. What is going to be dx1 dx2? This is pretty easy to do. Takes the partial derivative of the function with respect to x1, then dx1, and then partial derivative, and with respect to x2, then dx2. And the trouble over here is the denominator over here. So what should we do? Should we take the derivative of f1 over f2 with respect to x1, x2 like the way we do over here, or do something else? And then here is the idea. Look at the right-hand side. The right-hand side, we have these two partials, this one and this one over here. So really, we just need to use the formula of the differential. So we do this like this. So dm is partial m partial x1 dx1 plus partial m and x2 dx2. The reason is that way we see these two expressions. We already have them over here. So we can actually see they are getting rather close. So, and that's the idea. So now we put them inside. Partial derivative with respect to x1, this one over here is simply 1 over x2. With respect to x2, it's going to be x1 over x2 squared because x1 is a constant considered. So now put them inside, then we have 1 over x2 and dx1 on top. minus x1 over x2 squared and dx2 on the top. And then we have over here x1, x2, and then we have partial m and partial x1 dx1 and plus m dx2. That's like this. Of course, we knew beforehand this was the right approach. The reason is now we see dx1 over here and dx1 over here. We can take dx1 out. You may say why this is possible, because look at what's going to happen if we take dx1 out. And this is what we have. It's squared, and then we have trouble. Okay, and this is going to be dx2 over dx1. You may say, how do you know you can do this? This is the thing that about differential, that if you take out dx1, then this is really the derivative. It appeared in our implicit function differentiation as well. So now you have over here x1, x2, and m over here x1, and plus partial m, partial x2, and dx2 and dx1. Now we compare this one with this one. We see here we have a lot of f1, f2s. So what it means is that now we know this dx2, dx1 is negative f1 of f2. And put this one inside over here, and put this one inside over here, and then we have exactly what we need. So this is going to be 1 over x2 minus x1 over x2 squared, and then negative f1 over f2 in the numerator, and then denominator over here, this is what we have, x1 over x2, and then here we have partial m, partial x1, and plus partial m, partial x2, and minus f1 over f2. Now it's just a simplification problem. We just need to multiply here by x2 squared and f2, and here by also x2 squared and f2. And that's exactly what we need. Okay. So really it's try to matching both sides and the computation of partial derivatives. Okay. And for part B over here, we use the same strategy. If you look at what's the difference between this sigma and a sigma bar. Sigma over here we have m over, let's see, it's m dx1 over x2 and x1 over x2. In fact, this is just a elasticity. And if you look at sigma prime, and that's going to be negative m dx2 over x1, and then we have here x2 over x1 and dm. So we see these terms are already the same, right? So it has nothing to do with m. In fact, what we need to show is just dx1 x2 over x1 x2 is negative dx2 over x1 and x2 and x1. And we use the same formula over here for these. Just differential, of course. And then we can easily verify that's going to be true. Okay. So this is about problem 1, and quite a few of us had troubles.